So we will cover up with integration applied to inverse functions today. You should know that the only inverse function which is part of your course is tan inverse. And recap that we learned that the differential of tan inverse x was 1 over 1 plus x square. And in this model we will build upon this concept. The basics being that if you are given the differential as 1 over 1 plus x square, you should instantaneously identify that the integral would be tan inverse of x plus c. Alright. So in this model, you will build upon this concept of the differential of tan inverse. I repeat, tan inverse is the only inverse function which is part of your A2 course. So we advance concepts up a bit. So we have three main parts. The first is the integral of something like 1 over a square plus x square. The second part being, or the second concept being rather, 1 plus b square x square. And the last and final sub concept I'd say being something like a square plus b square and x square. So whenever you see something like this with an integration sign, your mind lights up like a light bulb, and yup, you do identify that this has something to do with tan inverse. Alright. So we do know that this has something to do with tan inverse, and thus the integral of any such function is tan inverse is in terms of tan inverse. But what else? So we look at the denominator. Since and we obviously have something next to tan inverse. I start off again since things are getting messed up. So the first thing is to identify that it's going to be in terms of tan inverse. We're going to have a plus c and something inside tan inverse. So the second thing in the denominator always goes in the numerator. The first thing in the denominator always goes in the denominator. Alright. And since the first thing in the denominator is not a 1, as in this case, we'll write that down in terms of a. And notice that whenever we have two things in the denominator, we have to write both in their simplest form, that in this case was a square. You have to write both in terms of a square. As in this case, I can also write 1 as 1 square, but we do know that the 1 is equals to 1 square. Alright. So moving on to the second sub-concept, identify that it has something to do with tan inverse. The first thing in the denominator is 1, so it's gonna be 1 in the denominator here too, so no need to write 1. And then we have b square x square. This can be written as bx whole square. For now I let it remain as it is and write down bx here with a plus c. The first thing in the denominator was a 1, so 1 over 1, so yeah, it's 1 basically, yeah. But there's one more thing too. One more thing, that this is not just 1 over 1, but this would also get multiplied with what's next to x. In this case, it's b. We must not ignore this b. This is a very common mistake, and I don't want you guys to make this. And then we have a tan inverse. We identify this first. and in the numerator here we'll have the second thing in the denominator, which is bx, and a a in the denominator and plus c. We must have something here since we have an a and a b, so a multiplied by b. Alright, so now we do have the three basic sub-concepts when it comes to integration applied to inverse functions. We move on and now take numeric examples. Let's write this down as pointers since these are sub-concepts, and then moving on, our first example. Let that be something like 1 over 1 plus 49x squared. So first of all, write this in its simplest form, which I can write as, so we have a 1 square plus 7 square and an x square. So this equals to, first of all, you do know that it has something to do with tan inverse. We have a 1 and a 7, so 1 multiplied by 7, and the second thing goes in the numerator, so we have 7x here, and the first thing goes in the denominator. So in its simplest form, we can write this down as 1 over 7 tan inverse and a 7x, and yeah, a plus c since this was integrated. Then our second numeric example could look something like this. Let's say we have 1 plus 4 plus x square. X square is always the second and we cannot like switch the position, alright. X square must always be second for the integration of tan x to happen. So first of all, write this in its simplest form. The constant comes first and then we have x square, which cannot be simplified further. So we do identify that this has something to do with tan inverse. First things first, over 2, alright, and then we have a 2 into a 1 which was here. Since you don't forget, there is no issue if you always write this down. And then we have plus c. Simplifying this, we have half into tan inverse x over 2 plus c. So this was our second numeric example. And then finally our last numeric example is example 3. Let's advance things up a bit and let's write this down as something like this. Simplifying this, writing the denominators in like as squares, we have something like pi square, the first number being the constant, and then a 6 square x square. This has something to do with tan inverse. We do know that. Then the second thing would be in the numerator. The first thing would be in the denominator. Then for what comes here, we have a first thing into second thing without the x. And then finally, simplifying this, we have a 1 over 30 tan inverse 6x over 5 and a plus c. So here we'll wrap up with integration applied to inverse functions. We started off when mentioning that tan inverse is the only inverse function we look at in our A2 syllabus, and we started building upon concepts from this basic concept. We looked at 3 possible different cases bit by bit, and then we finally had numeric examples.